I will
Okay.
report it.
Thank you.
So, okay, I finished the quiz. And could you please remind me, we will start from class 3, problem 4, yes?
Yes.
You also told us we did 3 B and C, but you told us that we would start this lesson again from them in order to talk about them again, as I recall. Because we didn't have much time on that and we didn't really talk about it a lot.
Yes, you told that you'll explain it one more time.
Okay, let's do number 4 and then number 3, B and C, okay? I think we can do it. So, let's start. We have Marcus' utility function. His utility depends on aerobic classes, it's good X, and gym visits, it's good Y. And this is his utility function. The price for each aerobic class is 10, the price of each gym visit is 8. His monetary income total 400. We should find the optimal bundle. Yes? How many aerobic classes and gym visits he will consume. And this is our task. What we should do? We should write down the utility maximization program. Yes? Let's write down it. Utility maximization program. What Marco does? He maximizes his utility by choosing X and Y, non-negative, subject to his budget constraint. Who can tell me the budget constraint? Artur, please.
Yeah. We price 1 to
Yes,
to
multiply.
to by X by plus Y we have 10. Sorry. Yeah. Of course we have the price. Okay. Plus 5 multiplied by 8.
Why 5?
Why
5?
by 10.
8 multiplied by Y. These are expenses on gym classes. Price of each class multiplied by the number of gym. And
Plus
then
равно 400. 400.
Okay, this is our budget constraint, budget set. Yes, all our expenses should be less or equal than our monetary income. What we should prove first of all, we should prove that we will spend all our money income such that here will be equality. We will work with budget constraint. How we will prove it? We say that if we will increase our spendings, for example, on Y, our utility will increase. Yes, you see this positive relation. Or if we will increase spendings on good X, our utility level will also increase. So our preferences are monotonic. Marcus' preferences are monotonic. So Marco will spend all his monetary income on buying X and Y. Agree? Then, from this utility function, we can see that preferences are standard. How it will look like. Draw the sketch. To goods X and Y, budget constraint. This is our budget line. If we will not visit gym, if Y is equal to 0, maximum amount of X is 400 over 10, 40. If we will not visit aerobic classes, maximum amount of gym visits, if X is equal to 0, maximal Y is equal to 400, our monetary income over the price of Y, over 8, it's 50. So this is our budget constraint. And we should find what we should do. We should find the highest indifference curve that will touch our budget constraint, yes? So something like this. This is the indifference curve, the direction of the utility growth, and the last touch. From here, we will find the best bundle, X star, Y star, our optimal amount of Arabic classes and gym visits. So how to solve this problem? What is the optimal condition? How to solve it analytically? Who knows? Anastasia, you know?
Well, I think we should present x, or no, we can present y in terms of x and put it in the formula, and then we can solve it to x. And when we solve it to x, we can solve it to y.
Yes, it's one mathematical method. Yes, first. But we'll, okay, first method. From budget constraint, you can find, for example, x, it is equal to 400 minus 8y over 10, yes, and put it into utility, yes. So utility will be the function out of y, it will be equal to 2 400 minus 8y over 10 multiplied by y plus 5 multiplied by 400 minus 8y over 10 plus 4y. And this you will maximize by choosing y non-negative. Yes, from here, how you will find it? You can open the brackets and say that this function is a quadratic function. The graph is parabola branches down like this. This is utility, this is y, and you will find something like this. Yes, and you will find the best y, which will give us maximal level of utility. Yes. So you will find y from here, and then put this y star into budget constraint once again and find x. Yes, you can do like this. It's easy, but we have the second method. The second method is economical method. Who knows how to solve economically? What is the optimal condition? Diana, you know?
I did it with the help of marginal utility. I don't know if it's correct, but I wrote that the marginal utility of x divided by price of x is equal to marginal utility of of y divided by price of y.
Exactly. Yes.
And
yes.
then I found the derivative. I found the derivative of utility function with respect for x and then with respect for y.
Exactly, yes. This is the economical condition, this one. We can revert it and say that marginal utility of x over marginal utility of y equals to the price ratio px over py. Px over py is the slope of the budget constraint. And the ratio of marginal utilities is the marginal rate of substitution. Yes, this is marginal rate of substitution of good x by good y. What is it? It is the slope of the tangent line to indifference curve. So I see. And you see from the graph that in optimal point, the slope of the budget constraint is exactly the slope of the tangent line to indifference curve, because the budget constraint is the tangent line to indifference curve. You see here? Yes. So this is the optimal condition, yes. How to find marginal utilities? You should take, as Diana has said, partial derivatives by x and by y. Let's do it. How to take partial derivatives? You consider, for example, you take partial derivative by x. You consider all other variables as constants. So for us now, x is only one variable and y is some number is constant. We consider it as constant. So please tell me partial derivative by x. If only x is variable, what I should write here? Dan, could you tell?
2y plus 5.
2y plus 5, yes, because you see here, for y, it's constant, and derivative from constant is 0, yes. And partial derivative by y, who can tell? Anastasia, could you tell?
Yes. It would be 2x plus 4.
2x plus 4, yes. Yes, because 5x is constant for us right now. So you understood, yes, how to take partial derivatives. And this should be equal to the price ratio in optimum. It is 10/8. Yes. So we solve this. 2y plus 5 multiplied by 8 equals to 10 multiplied by 2x plus 4. From here, open the brackets. 16y plus 14 equals to 20x plus 40. 40 we delete. And what we get? 4y equals to 5x. This is the optimal proportion in which we will consume our two goods. But here we have only, this is optimal condition, but here we have two unknowns, but only one equation. Where we have to put this? What we also know.
To the budget line equation?
Yes, yes, exactly. So we should spend all our money. Put this into budget constraint. So it will be 10x plus, you see, 8y. Instead of 8y, we say it is 10x. So 8y is equal to 10x. So instead of 8y, we write 10x. It is equal to 400. From here, we find that optimal amount of x is how much? 20. Optimal amount of y equals to
25.
5/4 multiplied by x star, it is 25. So this is our optimal point. This is the answer to our question. Guys, please questions about this. So you can solve with first method, but it's mathematical. It's not so interesting for economists. You can solve with economical method. Economical method, one more time. For interior solution, method 2. For interior solution, what that means? When we consume both goods, strictly greater than 0. Marginal rate of substitution of good x by good y in this optimal point should be equal to the price ratio of these goods, and budget constraint should be held as equality. Or like this. This is the system of two equations with two unknowns. So from here you will find x star, y star. Okay? Please ask questions about this point without raising hands. Questions? No? Okay.
Can I ask?
Yes, please.
Here, when you write about the budget constraint, where for y is equal to 5x, what does it mean 8y is equal to 10x? I'm not understanding.
If 4y is equal to 5x multiplied by 2, it's also true that 4y is equal to 10x, yes?
Why should we do this?
To put it into budget constraint for simplicity, because our budget constraint 10x plus 8y equals to 400. So I wanted instead of 8y to write down something with x. Okay?
Mm-hmm.
So I know that 4y is 5x, so 8y is 10x. And that's all. So instead of 8y, I write 10x. Yes? Questions? Other? Please, guys? No? Okay. So then let's do number 3. In number B, in point B. Show graphically that a person might choose more calls under option 2 than option 1, than under option 1. Now we know what means to choose. To choose is to find the optimal point, the best point. Yes, the best bundle. So let's see how our budget constraints are allocated to each other. First, this was second. Okay, so first one was like this. It's for first. And for second, it was like this. Second option. You remember, yes? It's open your previous class. This for second, this for first. And we should find such best points for preferences of our guy, such that under option 2, he will choose more calls. Here calls, X is for calls. Easy. For option 1, the last touch will be somewhere here. Yes, and this will be number of calls under option 1, best one with star. And for example, here will be the last touch for option 2. The utility grows to that direction. This will be the number of calls, call star under option 2. You see how I draw indifference curves. This is indifference curve best for option 1. This is indifference curve best for option 2. You see how I draw these indifference curves. They will never intersect each other because it is violation of monotonicity or all these things. So indifference curves, they should not intersect each other. So I draw like this, and then high indifference curve under option 2 like this. You see? So never draw like this. This is a very, very big mistake. You will get 0. Difference curves never intersect each other.
Like never, even if we have like the same utility but with different I don't know, maybe phone operators or something like that that have the same tariffs. So basically they have the same utility. Can they intersect, or can we draw it on the same function?
For 2 consumers?
No, we have one consumer.
One consumer, and consumer have and consumer
have 2 phone operators who have the same I don't know, same tariffs on the phone call. Then we put it on the same graph, on the same function, I would say.
One more time. This all is drawn for our consumer. He has 2 options. Option 1 from telephone operator of option 2. These are his budget constraints of the consumer. If we will have one more tariff operator, our guy will have, I don't know, third option, third budget constraint. But here we solve utility maximization problem of our consumer. He has his own preferences, only one preferences with his own indifference curves. It's not about different telephone operators. It's about our guy.
I'm not about this example in general.
So if we will have different
like the same tariff, tariff on the calls, but from different operators, can we draw it on the same curve, or it will be 2 separate curves?
One more time.
We
Tariffs.
have the same price, but different sellers. So the same utility.
So
Sellers of coals, I don't know. Can we put it on the same not graph but function?
one more time. Tariff operators. Tariffs is about budget constraints. So if two tariff operators give us same tariffs,
Yeah.
so budget constraint will be, for example, first for our guy, it's the same line, budget line.
Yes, yes. Okay, so that's the question. Thank you.
Okay.
Can I
So-
also ask a question? When we put the x1 and x2 and put it down, are these just random points on our lines, or there was some logic? Like why the first was x1 and it was at that exact point? Or like why wasn't x2 first and then x1?
Why here x1 and here x2?
No. Like when we are drawing these lines, we have x2 higher than x1 and to the right. Could it be that like x2 is to the left of x1 and it is first? Like firstly it calls 2 and then it calls 1 on the x1 voice.
Our task right now in point B is show graphically that a person might choose more calls under option 2 than option 1. I showed the example. Under option 2, under option 2, he will have more calls than under option 1.
And we can choose random points, so there is like anywhere we want.
Such that under option 2, he will make more calls and more calls.
Mhm.
And that's
Should it be before they intersect, or it could be after they intersect? Or necessary to do it before?
You cannot do maybe let's check here and I don't know, like this. Maybe, why not?
Mhm.
But it's not rational for him because I think it's okay. Yeah, it can be like this also.
Okay, thank you.
Yeah. Good question. Yeah, if we switch from option 2, yes, to option 1, we will be better off. And if we switch from option 1 to option 2, we will be worse off, but make more calls. Yes, why not? Good, thank you. C. Show graphically that a person might choose not to have any phone service under option 1 while choosing service under option 2. Also easy, I will show. One more time. This is our budget line for option 1. You remember about this point?
Yeah.
One point, yes. It's for option 1. For option 2, we
It
start...
was 100, yeah?
Yeah, 100, yes. And here 80, as I remember.
Yeah.
This is for option 2. So under option 1, we should choose no calls. No calls under option 2. Where is my red? So we will choose this point under option 1. This will be our best indifference curve under option 1. I see best for option 1. Agree? Under option 2, the best point will be somewhere here. Indifference curve for option 2, best point. And you see that on axis of calls, here calls, when we have option 1, we will have no calls. Calls under option 1 equals to 0, and under option 2 we will have calls, some amount of calls. Calls under option 2, optimal height greater than 0. Yes, like this. and show the direction of the utility goes. Okay. So in
Yeah,
point
can I
B,
ask a question?
please. Yes, yes.
To show graphically the промежуток между 100 и 80. То есть тоже синим цветом выделить, как часть графика, как часть опции первой.
Смотрите, дайте я так отвечу, да, здесь по-русски задаете. Если вас просят нарисовать budget set, да, множество, потребительское множество, то вы рисуете все, да, то есть вот там целая область, да, рисуете, и вот это нам доступно, и все вот эти точки, и все, что под бюджетным ограничением, нам все доступно. Вот. А если мы рисуем budget constraint, да, то есть ограничения, да, уже то тут выколотая точка, это одна нам доступна, это самое лучшее, да, это когда мы все деньги тратим, да, это budget constraint, budget line. А сейчас у нас здесь нарисован budget line. Вот это самая лучшая точка, когда мы все деньги тратим. Нет, на самом деле, нет, вот для бюджетного ограничения мы должны тратить все деньги, значит, вот эта точка, а здесь выколотая будет. Вот, в зависимости от того, что нас просят нарисовать. Okay, let's start our next class. Number 1 from class 4 is also the problem about utility maximization. Let's write down. Boris spends all his monetary income of M on goods 1 and 2. So monetary income M, price of good 1, price of good 2. Boris' preferences can be described by the following utility function. Utility depends on consumption of good 1 and good 2 and is equal to minimum out of square root out of x1 and x2. We should derive demand functions for good 1 and good 2. So we should find x1 demand and x2 demand. These are the same optimal points, but we don't have here numbers, but constants. So this will be optimal points, but with constants. But utility maximization problem is the same. So please, Anna, could you tell me the utility maximization problem that we will solve?
We must follow two conditions to solve this problem. First of all, we should have a budget constraint. As I understood, it's P1x1 plus P2x2 equals M.
Less or equal to M?
Yeah, yeah. And we should have the condition of the, like was in the previous task with the marginal utility of good 1 divided by P1, and it is equal to marginal utility of good 2 divided by price of the good 2.
But this was the optimal condition only for good preferences. And here we have the function of minimum, and this they are not so good preferences. But I asked about utility maximization problem. Utility maximization problem, we should maximize our utility, x1, x2, minimum out of square root out of x1, x2. This we will maximize by choosing x1, x2, non-negative. This is our first what we should write down. And we should prove that we will spend all our monetary income. Here will be equality, that we will work on our budget constraint. Why? Because if we will, for example, increase spendings on x2, our utility will increase. Yes? Or here.
Okay, so like in the end, the mean is like doesn't matter at all because we have this maximization program, or it still matters?
What doesn't matter?
Like mean sign before the function.
This one?
Yeah, yeah.
Yes, so we will have equality.
No, I mean the минимум. Перед функцией вот корень из x1, вот это вот.
That's a very good question. Who knows how indifference curves look like for function of minimum? Who can tell? Please tell who knows.
What exactly?
How indifference curves for such utility function will look like?
Like angle?
Angle, yeah.
Angles, yes, and they are not typical. It's not typical. It's for perfect complements, yes? Function of minimum. How we understood this? Let's see. So fix the utility level as constant utility level, and this should be equal to square root out of x1 if square root out of x1 less than x2. Agree? Minimum from these two things.
Yes.
And be equal to x2 if square root out of x1 bigger than x2. Or you can put here equal also, it doesn't matter. So this is the function, the utility function. Constant utility level is really some number, some constant. So how we will draw it? So second row, x2 equals to some constant if x2 less or equal than square root out of x1. What is this function? X2 equals to square root out of x1. How it will look like? It is the branch of parabola. You know this, yes?
Mm-hmm.
Like this.
Yeah.
X2 equals to square root out of x1. So if x2 less or equal than square root out of x1, it's under this function. Yes? Or yes, x2 will be equal to some constant. X2 equals to some constant. Like this. If we are under this graph. And our utility level constant will be equal to square root out of x1, this one. From here, we will find x1 equals to this utility in square, but it's also the number, it's also constant. So if x2 greater or equal than square root out of x1, it's above this graph. x1 will be equal to some number, u square. This is our angle. You remember this, yes? Yeah. So this how to write down analytical and how to draw the graph from analytical function of perfect complement.
And do we need to set the budget constraint?
Yes. After I will show, and then we will draw the budget constraint. So this is the indifference curve, one of indifference curves, and you see that this angle lies on this branch of parabola. That matters here. On this branch of parabola, when these two parts of minimum, when they are equal. So all these angles lies on this branch of parabola when x2 equals to square root out of x1. Then let's move on. One more time, I will draw. Now let's solve graphically our utility maximization problem. Here x1, here x2, budget line, like this, budget line. And here will be, if we do not spend money on x2, we will spend all our money on x1. So divide monetary income on the price of this good. Here, vice versa, yes, monetary income over the price of good. So if we do not spend money on x1, agree. Then how to maximize our utility? We should find the highest indifference curve that will touch our budget line, the last intersection. But we know where it will be, yes? This angle, direction of the utility growth, and we know where this angle lies on this branch of parabola, yes?
Mm-hmm.
And this will be our x1 star, x2 star. So our optimal condition here, how to solve this problem, is not marginal rate of substitution. Marginal rate of substitution here is 0, here is infinity. We cannot solve using marginal rate of substitution because we don't have like this indifference curves. Yes, they are not standard. So we use our knowledge about where these angles are located. So our solution in optimum what we wrote, x2 should be equal to square root out of x1. Yes, you see from where it is. And also budget constraint will hold with equality. Yes, we will spend all our money. P1 x1 plus P2 x2 equals to m. This is the solution for such utility function, for not standard utility function. Okay? Guys, you wanted to ask something or to answer something, please?
Answer.
To answer about what? How to solve this?
Yeah, just in general, if you would ask. But no.
Okay. So let's one sec. I want to solve it quickly, and then I will ask you next tasks about elasticities. Okay. So this one.
The second one, you mean?
Yeah. Because here we need only to solve. So from the first row, from here, x1 equals to x2 squared. Agree?
Yeah.
Put this first row into second. It will be p1 multiplied, instead of x1, we write x2 squared plus p2 x2 minus m equals to 0. This is the quadratic equation, you see? Quadratic equation. So we should find d. It is b squared minus 4ac. You remember. p2 squared minus plus 4 p1 m. Then x2 will be equal to first root minus p2 plus square root out of p2 squared plus 4 p1 m over 2 p1. And the second root will be with minus p2 minus square root out of d over 2 p1. What root we will take? Please, Valeria.
1 second. I think the first one.
Why?
Because it's bigger than 0, no?
Yes, exactly. Because we cannot consume minus 2 bananas, yes? And the second root is with minus. Here, minus is negative. Yes, we are economists. We cannot take this minus 2 bananas. Less than 0, so we will not take it. Not take. So the demand for good 2 will be equal to this first one. Yes? Minus p2 plus square root out of p2 squared plus 4 p1m over 2 p1. How to find the demand? And this is exactly greater than 0 for each income and prices. You can check it. How to find the demand for good 1? Very, very fast. Who knows? Anastasia, you know? The demand for good 1.
Well, we should present. No, I don't.
Please answer. Who knows? Without raising hands.
Really quickly, we can repeat the same as with finding x1 for good 1.
What we have in optimum? X1 equals
we can put it in the equation which we have in the system. We
know
already
yes.
we know x2.
We know that in optimum x1 equals to x2 squared. So the demand.
So we know that it is the square of x2.
So this will be in square minus p2 plus square root in square. And that's the answer for the demand for first good. Then what about point B in this task? Are these goods normal or inferior? Who knows? Anastasia, how to answer?
Well, I guess these are the normal goods
Why?
because they are consumed together, and the consuming is like elasticity is more than 0. So if there would be inferior, then elasticity would be less than 0.
So you tell us that we should count elasticities, yes, to
No, but
answer.
it's in general because they are the complements. It means that they are cross. This cross elasticity will be positive.
We do not consider them as the complements or substitutes. We don't speak here about cross elasticities. Normal or inferior goods. It's about income elasticity here. Christina, you know?
I want to ask a question. We wrote previously that x2 was less than 0. Can we say that that's why it is inferior? Or we cannot count it as such because we didn't take it? I don't understand.
When we solved quadratic equation and we found one root greater than 0 and one root less than 0. Yes, it's about this.
Mhm.
We cannot take this root because our demand cannot be negative. I think you speak about elasticities, but here not elasticities. Here are demands. Demands. How much I want to buy? I cannot buy minus 3 apples. Yes, I can buy only 5 apples or want to buy.
So can we say about this answer that it is a normal one as demand increases as income increases?
Exactly. Yes, you see that higher the monetary income, higher the demand for a good tool, and here also greater the demand for greater monetary income gives us higher demand for good one, and that's all. And that's all. So we make the conclusion that they are normal goods. Guys, did you get it? It's okay how we showed it.
Yes.
Thank you. Next. Number 2. Suppose that demand for a product is given by, so this is the demand, 12 minus P. Then table with the price, quantity demanded, elasticity of the demand by price, and total revenue. Let's fill in the table. Price 11,975,331. Quantity 1357,911. So our first task is to find elasticity, to fill in about elasticity. Table. What is the elasticity? Okay, Aida, please. What about elasticity?
So we know that the formula of the elasticity is minus B, which is multiplied by PO, which is divided to QO. So in the first line, we can see that elasticity is gonna be minus 1, which is multiplied to 11 and divided to 1.
Multiplied by minus 11, yes, in total.
Minus 11, yes.
Then
And total, okay.
Elasticity, please.
Minus 3, which is multiplied to 3, minus 9.
Over 3, yes?
Oh, 3.
Minus 3, okay. Then?
Wait, why we have to be okay. Minus 5, which is divided to so minus 1.4.
Minus 705, it's minus 1.4, yes?
Minus 0.71.
Mm-hmm.
Minus 0.33.
Mm-hmm.
And minus 0.09.
Mm-hmm. Okay, thank you. So how we found this formula? Let's see. By definition, elasticity of the demand by the price of this good is the change in quantity demanded in percent over the change in price in percent. Yes, the percent changes. Yes, it's the reaction of the demand on percent change in price. So what is it? How you know? I hope you know the formula of percent change. What is it? It is what we have now minus what we have before, what we had before over what we had before multiplied by 100%. It's from calculus. Yes. So let's write down here all this. So it's Q2 minus Q1 over Q1 multiplied by 100% divided by, I will erase this, P2 minus P1 over P1 multiplied by 100%. You can delete from numerator denominator 100 and revert. What you will have? Q2 minus Q1 over P2 minus P1 multiplied by P1 over Q1. So this point from which we start. Also, we can write that this is change in quantity demanded over change in price, not in percent, but in dollars and units. Yes, multiplied by price over quantity that we had first. And if these changes are very, very small, if this change is almost zero, we can take the limit. And this is the definition of the derivative. This is the definition of the derivative by price of the demand. You see? So this will be the derivative out of price multiplied by price over quantity. And from our quantity demand, from our demand function, take the derivative by price, it's minus 1. You see? Take the derivative by price, it's minus 1. So here we have, for our demand function, here we have minus 1 multiplied by price over quantity. And so we got this formula, and we found all these elasticities from the table. Okay. Then, what about total revenue? Who wants? Alina? Oh, Amina, sorry. No? Okay. You all answered. Valeria, please.
Total revenue for the 11 will be 11. Then it will be 27 for 9, for 7 and for 5 it will be 35, and it will be the maximum revenue, total revenue for all this table. The third one is also 27, and the end is 11 again.
Good. And we see exactly the total maximal total revenue is 35 when our elasticity, you see, elasticity is very close to minus 1. Yes? Elasticity close to minus 1. Let's prove that maximal total revenue will be when elasticity is exactly -1. Let's prove it. Let's write down, first of all, inverse demand function for our function. Inverse demand is 12 minus quantity. You understood what I did? I found price. Okay, so total revenue is the inverse demand multiplied by quantity, price multiplied by quantity. It is 12 minus Q multiplied by Q. Open the brackets. 12Q minus Q squared. It is quadratic function, graph parabola branches down. Yes, and we can find the highest, the maximal total revenue from here. Maximal total revenue when Q, let's write down. Q equals to how much? Minus B over 2A minus 12 over minus 2, 6. Yes? When quantity is 6, our total revenue is maximized. So total revenue maximal is how much? 6 multiplied by 6, yes? 36. Let's prove that, what about elasticity when quantity is equal to 6? Put this quantity into our elasticity formula. Elasticity when quantity is equal to 6 is how much? -1 multiplied by the price. The price is 12 minus 6 over 6. You see that it is -1.
Yes.
So total revenue will be maximal when elasticity is -1 for linear function. We can show it everything on the graph. For our example, please draw two graphs, one under another. Here quantity, here price, here will be total revenue. This is our inverse demand function. Demand, here 12, here 12. Yes. Here 12, here 0. Total revenue maximal in the middle, 6, like this. And this quantity 6 is the middle of the demand. And we know that when quantity is equal to 6, elasticity is -1. In this point, elasticity is equal to -1. I want also to write down two other points. This point, highest point of the demand. Quantity here is equal to 0, price is equal to 12. What is elasticity? Elasticity equals to how much here? Count, please.
24, no?
No, this is our formula for one more time. Elasticity now here minus price over quantity. Quantity in this point 0, here 12. Minus 12 over 0 is how
0.
much?
Doesn't
No.
exist.
It's minus infinity. Yes, minus infinity.
Yes.
And in this point, when price is equal to 0 and quantity is equal to 12, elasticity equals to how much?
0.
0, yes. So 0 over 12, 0. So you see that we can count elasticity in each point, yes, on our demand function, and it will be different. But what we see that when we move to the left, elasticity is growing. Yes, the reaction of buyers is growing. And when we are in this part from 0 to -1, here what we can say about our demand. This part is inelastic. Yes, you know that when elasticity is from 0 to 1 by module, here we have inelastic part of the demand, inelastic. And when elasticity is from -1 to -infinity, what that means? That means that the percent change in price will change our quantity demanded more than 1%. So a very strong reaction of buyers. So here is the part, elastic part of demand. And what you can tell me, my question, if we work on the elastic part, what we should do with the price to increase our revenue? Please answer for once. If we work on the elastic part, what we should do with the price to increase our revenue? Anna? No?
Well, we should make the price higher, increase it by 1%.
If we work on the elastic part, if we will increase the price, quantity will decrease.
Demand will be lower. So I think we should decrease probably price.
Yeah, we should
Yes,
decrease.
we should decrease the price. You understood why, yes? If we
Yeah,
will
yeah.
decrease the price, quantity will increase, and here we have total revenue closer to maximum, yes?
Yeah.
And if we work on inelastic part, it will be vice versa. We should increase the price in other color. We should increase the price to move here, yes? Quantity demand will decrease, but total revenue will increase because we have inelastic demand, inelastic part, yes? Closer to maximal total revenue. And the total revenue will be maximal when elasticity is equal to -1. This all for linear function, linear demand function. All for linear demand function. Okay, so next. Suppose the demand curve shifts to the right with 2 more units sold at each price. Is the new demand curve more or less elastic than the old one? So we had before like this, 12, 12, yes, demand D1, and now it is 14, 14, D2. Shift here. What we can say about elasticity? Who knows? Anastasia? No?
Well, I guess we can say that the elasticity will stay the same, maybe.
Yes, in general, we have the same. Here we will have minus infinity, and here we will have minus infinity. Yes, in the middle we will have -1, and here we will have 0. Yes, so in general it will
proportions of elastic and inelastic parts.
the same proportion. So middle part, in this part elastic, this part no. So in general, yes, in general, no change. No change in elasticity. But one more my question. But for each price, what will happen? For example, for each price, constant. So take any price, for example, like this, constant price. We move from this point to this point. Elasticity now is lower or higher? More elastic or more inelastic? Our demand.
More inelastic.
More inelastic because we move closer to 0. Yes.
Mm-hmm.
So here will be more inelastic. And for constant quantity, for each quantity, for example, like this, Q constant, for each quantity constant, we move from here to here, yes? What we can say?
More elastic.
More elastic, because we move closer to minus infinity, yes? More elastic. Yes. So please ask questions about this number.
I'm not really sure, but why the P constant more elastic?
Because
So-
if we fix the price, so we move from this point to this point, and this point, new point, is more far away from -1, for example. It's closer to elasticity 0. Yes?
So elasticity will decrease? Am I
Yes.
right? Ah, okay.
More inelastic.
Yeah. Ah, okay. Thank you.
So one more task we should do. Number 3. We have different elasticities. Elasticity of good X by its price -2. Elasticity of good X by its income is 1.5. Elasticity of good X by the price of good Y is -0.8. Elasticity of good X by the price of good Z is 0.5. Point A. Suppose that at the current price, the firm is able to sell 1,000 units of good X per day. So X1, first point, 1,000. Had it cut the price of X by 1%, cut the price. So change in price of good X in percent is, attention, -1%, yes? Here, -1, cut the price. That matters here. Then, how many more units of X would it be able to sell daily? So the change in X, how to find it? Not in percent, you see, in units. Valeria, please.
Yeah. 1 second.
What elasticity we should use?
X divided by P. P.
First
X
one,
per-
right? This one.
Yes, of course.
Okay, so what means elasticity of good X by the price of good X is the percent change in good X, yes? In the
Yes.
good X by the percent change in the price for this good. And what we know, that it is equal to -2, and also this one also knows it's -1%. So what conclusion we make?
X percent equal plus 2%.
Plus 2%, yes, good. So here plus 2%.
And
but
then
in units. And in units, how much?
yeah, so it's gonna be 0.02. 0,2.
In units. So we had one side.
It's gonna be 20.
20, yes?
Yes.
And plus 2% more. 1,000 plus 2% more in units, it's 20. Good.
Yeah.
I can write it. So one more time. Percent change is the change in X in units over X1 first, from which we start, multiplied by 100. And we know that it is equal to 2%. So change in X equals to 2% multiplied by 1,000 over 100%. And this is 20. Yes, the change is 20 units. Good, thank you. B. If this firm wanted to increase its revenue, would it rather make sense to raise the price of X or lower it? I hope you can answer it now. Anastasia, what we should do? Lower. Why? Why?
Because if we increase, then if we put it in our formula, it will give us the minus unit. So if we implement delta P in terms of plus percentage, then we will have the minus percentage in elasticity, and that will be no, it will be minus percentage in delta X. So the delta X will be not plus units, but minus units.
No, we have low the demand. So
Yeah.
if price increases, the quantity demanded decreases, and vice versa. It's not about this.
No, well, we can say like this, yes.
Valeria, you know how to answer?
I don't know.
Okay, I will. It was in the previous task I showed you. So, what we know about this elasticity? Elasticity of good X by its price. It's -2. It's elastic or inelastic demand?
Elastic.
Elastic, yes? Elastic demand. Because it's between -1 and -infinity. Elastic demand. What that means that 1% change in the price will change the quantity demanded by more than 1%. Yes?
Mhm.
What is total revenue? Total revenue is price multiplied by the quantity, by X. So, for example, if we will decrease the price of good X by 1%, I don't know, quantity demanded for our good will increase by more than decrease in price. Yes?
Then total revenue will be increasing too?
Yes, yes, yes. So you see arrow down and 2 arrows up. So total revenue will increase. And it was shown in the graph in the previous task. When we work on elastic part, we should decrease the price to increase our total revenue. You answered me this, yes? We have elastic demand here, so we should decrease the price a little bit, such that a lot of consumers will come to us and total revenue will increase.
Yes.
Better. Okay, so next ABC. It's second B, sorry. What is about the connection of good X and good Y? If elasticity of good X by the price of good Y is -0.8, what we can say how good X and good Y are connected? We can say that they are complements or substitutes.
They are complements. No?
Complements or substitutes?
I think it's complements.
I think it's substitutes.
Okay.
Okay, let's see. You see that cross elasticity is less than 0. What that means? That means that if the price of good Y increases, then the quantity demanded for good X decreases, yes?
Yes.
Negative connection, yes, between them. And this is for what goods? For complements or for substitutes?
Substitutes.
Substitutes, yes. Yes.
For complements.
Yes. Oh my God. Yes, yes, yes. Complements.
Yes.
Yes.
Mm-hmm.
And the second one, 0.5 will be substitutes.
Mm-hmm. 0.5 greater than 0. Yes, what that means? Positive connection. The price of good Z increases, then the demand for our good, for good X, increases. So Z and X, they are substitutes. With examples, you see, if the price for mobile phones increases, then the demand for SIM cards decreases. So mobile phone and SIM card, they are complements. If the price for Pepsi increases, then the demand for cola also increases because consumers begin to substitute more expensive good with a less expensive one. So cola and Pepsi, they are substitutes. Is it clear, please, guys?
Yes.
Yes.
Okay. And the last one, C. If consumers' incomes increased, would they buy more of good X or less of it? Would the budget share of good X rise or fall? So if income will increase, would they buy more of good X or less? It's about income elasticity. What we know about income elasticity? Elasticity of good X by income equals to 1.5. So what we can say? if income increases, then the
X will
quantity demanded increases because
Yep.
greater than 0. Yes, increases. So, we make the conclusion that it is normal good, not inferior, normal good.
Yes.
Normal. Then what about budget share? Budget share. Budget share, this how much we spend, what share we spend from our income on this good. So our expenses on this good is price multiplied by quantity. Expenses on this good over our income, this will be budget share. Agree?
Mhm.
What we also see from elasticity of good X by monetary income, it's 1.5. What that means? That means that if our monetary income will increase, our quantity demanded will increase more than monetary income, more than 1%. Yes, it's greater than 0 or greater than 1 also. So what about budget share? Budget share in total will increase.
Everything will be increasing.
Will be increasing. Yes, increases in total. How we name such goods?
Luxury. Is it luxury good?
Luxury goods, not necessities, but luxuries. Yes. So here we make the conclusion that this is luxury good. So that's
Luxury,
all.
luxury because salary is increasing, then people have the ability to buy more luxury goods. Am I right?
They not have ability. They have ability to buy more. They will buy more. So
Okay.
what that means? Luxury goods, elasticity of good X by good by income greater than 1. What that means? The change monetary income, for example, is 1% increase, and my quantity demanded increases by more than 1% plus. That means that I want to spend more than my money income increases in percent.
Okay.
This is the definition of luxury good, and that's all. So that's
Thank
all
you.
about this point. Yes. So guys, I'm sorry that we are late as always. Please prepare number 4 for the next class, for the beginning of the next class. Please prepare, and
Okay.
we will make like quick answers for number 4. So okay, thank you. See you next Tuesday. I recommend you to read lectures carefully, to read your textbook, your task, to read a little bit what we will have on the class, or the task of the class, and try to solve something by yourself after the lecture. Maybe it will be useful for you to understand, because we have very high speed, yes, of explanation. So be prepared before the class for such reasons. Okay.
Okay, thank you.
Okay, thank you.
Thank you, bye.
Goodbye.
Bye.
Thank you.
Okay, goodbye.
Bye.
Bye, thank you.
Bye.
Полина Анатольевна.
Да, я помню.
Да.
Давайте. Все, народ, уходим, у нас тут разговор.
И запись тоже можно, наверное.